Today's question is e raised to power of ln x over x, that is equal to square root of I. Our goal is to find the x value, and x value have to show in the form of a plus ib. Let's see how to solve it. Usually if we have a x in the exponent, what you have to do, we are going to take the logarithm and we are going to find the value of x. But in the left hand side, in the exponent, we have a logarithm of x. Already we have a logarithm of x. So in this case, how can you solve it? And where we have to start? We have to start from e raised to power of ln x over x, or you have to start from the right hand side, which is square root of I. Let's see in detail. I am going to start by the right hand side, which is square root of I. First I am going to show you what is I. To find the I, you have to recall the Euler's identity, which is e raised to power of I theta, that is equal to cos theta plus I sin theta. Our goal is to find I value, so that's why instead of theta I am going to substitute pi by 2. So then e raised to power of I times pi by 2, that is equal to cos pi by 2 plus I sin pi by 2. And we know that cos pi by 2 the value is 0 plus I times sin pi by 2 the value is 1. So the right hand side 0 plus I, which gives only I. So that is equal to e raised to power of I pi by 2. So we found the I value. We have square root of I. Square root of I, we can write it as I raised to power of 1 over 2, isn't it? I is e raised to power of I times pi by 2 whole raised to power of 1 over 2. Now it is in the form of a raised to power of m whole raised to power of n. So we can write this as a raised to power of mn. Use that property here. So then we can write this as e raised to power of I times pi by 2 times 1 by 2, which gives e raised to power of pi over 4, isn't it? So what is square root of I? Square root of I is e raised to power of I pi by 4. Left hand side we have e raised to power of ln x over x, that is equal to square root of I. So instead of square root of I, we are going to write e raised to power of I times pi over 4. Now observe here, bases are same. If bases are same, we can equate the exponents. Let's use that property. Ln x over x, that is equal to I times pi over 4. At the numerator, we have a ln x term. At denominator, we have a x term. It is very difficult to find the value of x. That means this is a transcendental equation involving a complex term. So solving this, we require a Lambert W function. Lambert W function definition is W of a times e raised to power of a. If we have in this form, you can simply write this as a. But our expression, it is not in the Lambert W function. In the Lambert W function, we have a exponential term. But in our expression, we don't have exponential term. So that's why instead of x, I am going to write e raised to power of ln x. Here e and logarithm functions are opposite function. Once gets cancelled, you get only x. So that's why instead of x, I am going to write e raised to power of ln x. E raised to power of ln x, that is equal to I times pi over 4. Our Lambert W function is in the form of a times e raised to power of a. But our exponential term, it is in the denominator. So you have to take it into numerator. Let's take. So ln x times this e raised to power of ln x, if you take in numerator, it becomes e raised to power of minus ln x, that is equal to I times pi by 4. Now observe here a and here a, and that means these two terms are same. But in our expression we have minus ln x, but here we have only ln x. So that's why you have to multiply both sides by minus. Here minus and here also minus. So now it is in the form of a times e raised to power of a. Here you have to apply the Lambert W function. Left hand side turns into simply a, which is minus ln x. Ln x is nothing but natural log, that means the base is e, that is equal to w of minus I pi over 4.
Here we have minus, so both sides multiply by minus.
Here minus times minus is become plus. Now use one of the logarithm property, that is, if we have a ln a with the base b, that is equal to some value, then this logarithm function we can convert into algebraic form, that is a equal to base raised to power of this constant. So use that property here. So then x equal to, our base is e, so e raised to power of minus w of minus I pi by 4. We have to show our x value in terms of a plus ib, isn't it? but this is not in terms of a plus ib, so we need to find in terms of a plus some numerical values. So that's why we are going to simplify this x term. First I am going to find the w of I times pi by 4 value. To find w of minus pi by 4, I am going to use series expansion. W of minus pi by 4, the general form is w of z, isn't it? Here z is minus I pi by 4. For this function, the series expansion is w of z, that is equal to summation n equal to from 1 to infinity minus n whole raised to the power of n minus 1 over n factorial times minus I pi over 4 whole raised to the power of n. Here I am going to find the w of minus I pi by 4 value. So what you have to do, first you have to substitute n as 1. So if you substitute n as 1, that is minus 1 whole raised to the power of 1 minus 1, which gives 0. So minus 1 whole raised to the power of 0, the value is 1 only. So simply we can write this as 1 over, we are substituting n as 1. So here 1 factorial. 1 factorial is nothing but 1 only. So 1 over 1, which gives only 1. So let's write 1 times, still we have minus I pi over 4 whole raised to the power of 1. The first term is minus I pi over 4 plus the second term, we are going to substitute n as 2. So if we substitute here, there is minus 2 whole raised to the power of 2 minus 1, which gives only 1, minus 2 whole raised to the power of 1, which is minus 2 only, over 2 factorial, which is 2 only. So after getting these two cancelled, we are going to get only minus 1. So let's take only minus 1 times I pi by 4 whole raised to the power of 2. Now observe the second term. I times pi by 4 whole raised to the power of 2, we can write as I raised to the power of 2 times pi raised to the power of 2 over 4 raised to the power of 2 is nothing but 16. So, and we know that I raised to the power of 2 is nothing but minus 1. So instead of I raised to the power of 2, I am going to write minus 1. So here minus 1 times minus 1, which gives plus 1. So the second term, it becomes plus 1 times pi square over 16. So that is the second term. So like that you are going to simplify few more terms only, not up to infinity. Now substitute n as 3. So if you substitute n as 3, we need to write minus 3 whole raised to the power of 3 minus 1, which is 2. Minus 3 whole raised to the power of 2, which gives plus 9. So just write only plus 9 over, here at the denominator we have n factorial, that is 3 factorial. We are taking n as 3, so 3 factorial is 6. So you just write 6. After cancelling these two, then you will get 3 over 2. So just write only 3 over 2 times, now we have to substitute n here. Let's substitute n as 3 minus I pi over 4 whole raised to the power of 3. Only simplify this part. So after split this, then you will get minus I over 3 times pi over 3 over 4 raised to the power of 3. So 4 raised to the power of 3 is nothing but 64. Just write 64 here. And I raised to the power of 3, that is minus I raised to the power of 2 times I. So, and we know that I raised to the power of 2, the value is minus 1. Just write minus 1 times I and times pi raised to the power of 3 over 64. Minus times minus, which gives plus. Plus times I is I times pi over 3 over 64. I times pi over 3 over 64. Plus, now I am going to substitute n as 4. After substituting n as 4, then you will get minus pi over 4 over 96. Now observe the third term. We have 2 times 64, so which gives 128. So just write 128 at the denominator. And we know that pi value is 3.14, isn't it? So if you divide it by 4, so after dividing by 4, then you will get 0.785. So the first term is minus I times 0.785. Now check the second term, which you have pi square over 16. So pi square, that means 3.14 whole square over 16. This value is 0.616. So just write 0.616 plus. After simplifying the third term, this value is 0.724i and the fourth term is 1.0146. The second term we have plus 0.616 minus 1.0146, which gives minus 0.3986. First term is minus 0.785 and here plus 0.724, which gives minus I times 0.061. This is the W of minus I pi by 4 value. But our x is e raised to the power of minus W of minus pi by 4. So instead of this W of minus pi by 4, you need to write minus 0.3986 minus I times 0.061. So after open the brackets, we get plus 0.3986 plus I times 0.061. It is in the form of a raised to the power of m plus n. We can write this as a raised to the power of m times a raised to the power of n. So we can write this as e raised to the power of 0.3986. 0.3986, it is nearly equal to 0.4, isn't it? E raised to the power 0.4 times e raised to the power of I times 0.061. E raised to the power of 0.4, the value is 1.49. Just write here 1.49. Now we need to find only this term. It is in the form of Euler's identity, isn't it? E raised to the power of I theta. So if we write in terms of Euler's identity, that is cos of 0.06 plus cos theta plus I sin theta. So sine of 0.06. Cos 0 of 06, the value is 0.998 plus I times sine of 0.06, which gives 0.0609. Here 0.99 is nearly equal to 1. So just write 1 plus I times 0.0609. I am going to write 1 plus I times 0.0609. 1.49 times 1, which gives 1.49 plus I times 1.49 times 0.06. After multiplying, then you will get 0.090. So now it is in the form of a plus ib. So we showed x in the form of a plus ib. I hope you like this content. If you like this content, please subscribe to my channel.